Hello and welcome to another exam paper walkthrough. Today we're doing something slightly different. Now that the summer 23 exams have been sat and completed, I can start to record videos of the summer 2022 exams. I find past papers one of the, if not the best forms of revision. Obviously the predicted papers are a slightly different direction, but in terms of out and out revision, I find past papers just outstanding. So this is the Summer 22 series, and I'm doing the paper 1H today. I hope you find this useful, and subscribe if you like. Okay, let's make a start then. So question 1, solve 7x minus 27 is less than 8. So I tend to treat this as an equal sign kind of, so I treat it as an equation. I keep it balanced. What I do to one side I do to the other side, but keep my symbol constant. There's a slight exception if I'm dividing by a negative number, but I always try and avoid that. So I'm going to start by adding 27 to both sides. So that's going to give me 7x is less than 35. Then divide both sides by 7, and I get x is less than 5. So I'm going x is less than 5. Okay, question 2. Write 124 as a product of its prime factors. So I tend to use a factor tree to help me with this. So I'm going to go 124, and I will always take off the smallest prime number first of all. So 2 times by 62, which is 2 times by 31. And then I've got my 3 prime factors. So write it as a product of its prime factors. I tend to write it in index form, so I'd write that as 2 squared times by 31. But I'm sure there's nothing wrong with writing it as 2 times 2 times 31. Okay, question 3. A delivery company has a total of 160 vans. The number of cars to the number of vans is 3 to 7. Each car and each van uses electricity, diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, the rest of the cars use petrol. Work out the number of cars that use petrol. You must show you're working. Okay, so I'm going to start with my ratio here. I've got cars to vans in a ratio of 3 to 7. So I've got 10 parts in total, and I want to split 160 between those 10 parts. So each part is going to be worth 16, which means that the number of cars, to be fair, it's the cars that I'm only really interested in. I'm not really interested in the vans. So cars is 16 times by 3, which is going to be 48. And now that I've got the number of cars, the cars are either electric, diesel or petrol. And the question really is asking us to work out this value here. So I'm going to say that if I know that 1/8 of them are electrical, then 1/8 of 48 is going to be 6. So let's just do 48 divided by 8 is going to be 6. So I know that there are 6 electric cars. I also know that there are 25% of the cars are diesel, so 25 of 48 is the same as 48 divided by 4. So that's going to be 12. And I know that I've got 48 in total. I've accounted for 28 of them. So if I've got 48, there must be 20. Sorry, I've accounted for 18 of them. 6 plus 12 is 18, which means that there must be 48 minus 18. There must be 30 petrol. So how many cars are petrol? 30. Right, question 4. Write 1.63 times 10 to the minus 3 as an ordinary number. So converting that into an ordinary number, the minus 3 really means that the number is going to start with 3 zeros. So I don't tend to do anything more complicated than that. Write the following number in standard form. So I place a decimal point somewhere to make it a number between 1 and 10. So 4.38 times by 10 to the, and I've moved my decimal from there. So I've moved it 3, 4, 5 places. So it's to the power of 5. And part C, work out 4 times 10 to the 3 times by 6 times 10 to the minus 5. So for this, I will always tend to treat my number part and my standard form or my index part separately. So 4 times by 6 is going to be 24. And then my index part, when we multiply index numbers, we can add the powers. So that's going to be times 10 to the minus 2. And then my final step is, this isn't in standard form because the first number needs to be a number between 1 and 10. So that's, if I converted 24, it would become 2.4 times 10 to the 1 times by 10 to the minus 2. So again, add the powers, it becomes 2.4 times by 10 to the minus 1. Question 5. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked with the X. So my method for this is I'm going to look at the exterior angles. So if I call them Z and Y, for now, Z is going to be equal to 360 divided by the number of sides. So in this case, a hexagon 6. So that would be 60. And then Y is going to be equal to, similar process, 360 but divided by 5, which is going to give me 45. So X is going to be equal to those two added together. So X is going to be equal to Y plus Z, or Z plus Y. So it's going to be 105. Question 6. Complete the table of values for Y is equal to X squared minus 3X plus 1. Part B, we're going to plot that, and then part C, use that to find a solution, quite a nice solution when it's equal to 0. Right. So this is quite time consuming on a non-calc paper. On a calc, we can use the table function, but we're going to have to work out our values for this. And we do that by substituting in these values for X. So if I, just as an example, when I put in 0, 0 squared, minus 3 times 0, so that's 0 minus 0 plus 1, so we get 1 for Y, so 1. I'm going to start with my positive values. We should also have a kind of a mirrored pattern here as well, but we will look at that. So when X is equal to 2, I'll do my work in just over here. So I'm looking at 2 squared, which is 4, minus 3 times 2, which is minus 6, plus 1. So that's going to be minus 1. So we've got that repeating pattern hidden here. So we expect this to be 1, but we'll find out. 3 squared is 9, minus 3 times 3, minus 9, plus 1, so that would be 1. And then 4, so 4 squared is 16, minus 3 times by 4, so minus 12, plus 1. That's going to give us 4, that's going to give us 5. And then hopefully, provided we do everything right, we should get 5 here as well. So minus 1 squared would give us 1. Minus 3 times minus 1 would give us plus 3, and then plus another 1 does give us 5. So that's our table filled in. We then need to plot that. So we're looking at minus 1 and 5. We're looking at 0 and 1. 1 and minus 1. 2 and minus 1. 3 and 1. And then 4 and 5. So your job is to join them up with as smooth a curve as you can. I would recommend you keep your wrist on the inside of the curve for that. I'm going to try and cheat. So I want to insert a shape and I want a curvy line. Right, let's try one more time with that. Insert shape. Okay, so if I click on each of these points now, it will automatically give me a curved line, so mine will look very smooth. And then double click on the final one. So there we go. Let's just make that match my pen colour. Ooh. Okay, so that's me having joined them up with as smooth a curve as I can. Obviously, you're going to have to do that freehand. I would recommend keep your wrist on the inside of the curve. Use your graph to estimate the solution of x squared minus 3x plus 1. Well, this is the equation of y being equal to that. So we want where y is equal to 0, which is going to be the horizontal line or the x-axis. So that's going to actually be my line. Again, that's not really showing up very well. Anyway, reading those points off, then we're reading that point and that point. So we're looking at, it looks like if that's minus, that's a half. So I'm looking at roughly x being equal to minus, 0.4 and 2.6. Okay, question 7. Here are two cubes, A and B. Cube A has a mass of 81 grams. Cube B has a mass of 128 grams. Work out the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers. Okay, so we're dealing with density. Density is equal to mass divided by volume. We've got the mass of these two. We haven't got the volume, so we're going to work out the volume. So if I look at the volume of cube A is going to be equal to 3 cubed, which is going to be 27. The volume of cube B is going to be equal to 4 cubed. I'm just pre-planning. No, it doesn't matter. Which is going to be 4 cubed, which is going to be 4 times 4 times 4, which is going to be 64. I'll talk you through a second method afterwards. I'll carry on with this one. I've spotted a slightly shorter, quick method, but I don't think I'll explain it as well. So the density of A is going to be equal to the mass, which is 81 divided by the volume, which is 27. And the density of B is going to be equal to 128 divided by the volume, which is going to be 64. So the density of A is going to be equal to 3, and the density of B is going to be equal to 2. So my ratio is going to be 3 to 2. What I was thinking, and I'll do this in a separate colour pen, so method 2, 81 is 3 to the power 4. 128 is 2 to the power 2, 4, 8, 16, 32, 64. So it's 2 to the power 5. So if I was actually doing this, I could have treated this and kept them like this, and I could have said that the density of A is going to be equal to 3 to the power 4 divided by 3 to the power 2, which would just be 3, and the density of B would have been 2 to the power 5, and then 4 cubed is 2 squared cubed is going to be, I've done that the wrong way around, is going to be 2 to the power 6 divided by 2 to the power 5, which would be 2. So I could have got those densities just by looking at the index form. But either way, 3 to 2. Okay, question 8. The table shows the amount of snow in centimetres that fell each day for 30 days. Work out an estimate for the mean amount of snow per day. So we've got a group frequency table, so we need to times our group, our midpoints by our frequency as our kind of a starting point. So I'm going to say that that's going to be 5 times by, 15 times by, 25 times by, 35 times by, and 45 times by. So that's going to give me 40, 150, 175, 70, and 135. So I now need to add up the total frequency and the total midpoints times by the frequencies. So if I add these up, units column first of all, so 5 plus 5 is 10. Then my tens column, 9, 16, 23, 27, 28, 29, 30. Um, 10, 20. So I think I've done that wrong. 9, 16, 23, 26, 27. Right, my pen's not working. And then 100, 200, 300, 400, 500. So 570. And then my units column, let's do it this way. Well, that 10 plus 8 plus 10, 8 plus 2 is 10, 7 plus 3 is 10, and then plus 10, so we've got 30. So we're doing 570 divided by 30, which we can do, cancel a 0, so 57 divided by 3 is going to be 19. So our estimate for the mean amount of snowfall per day is going to be 19. Okay, question 9. A cuboid is placed on top. A cube is placed on top of a cuboid, as the diagram shown, to form a solid. The cube has lengths of 4 centimeters. The cuboid has a dimension of 4 by 6 by 5. Work out the total surface area of the solid. So I'm going to do this as planning the question. So I'm going to work out the total surface area of the cube, total surface area of the cuboid. I'm going to add them together, but then I'm going to take away this bottom edge because that's not going to form part of the surface area, and I'll need to take away 2 lots of that. So total surface area of the cube is going to be equal to 6 times by the area of one face, 4 times 4. The total surface area of the cuboid is going to be equal to 2 lots of each of the dimensions multiplied. So 7 times by 6 plus 7 times by 5 plus 7 times plus 5 times by 6. So that's going to be equal to 6 times by 4 is 24. 24 times by 4 is going to be 48, is going to be 56. Just double checking my maths on that. Double that would be 48, and double that would be 56. So the total surface area of the cuboid is going to be 2 times by 7 times by 6 is 42. 7 times by 5 is 35, and 5 times by 6 is 30. So that's going to be 2 lots of, so 2 plus 5 is 7, and then 747, which is going to give me 28, 29. So I make that. So I need to add them together. So I need to do, actually, what I'm going to do is, in effect, I need to do 298 plus 56. And then from that, I need to minus 2 times by 16. So I've made a mistake here. I treated that as 70, I think. So let's look at that again. 3 plus 3 is 6, so that should have been 107. So that should have been 214. So I'm looking at, let's do it this way, 214 plus 56 minus 32. So I'm doing 214 plus 24. And I've just spotted another mistake. Not great. So always check your solutions, take your time. 2 plus 5 is 7. Okay, and the mistake I've spotted then, you might have spotted it as I was doing it. My mistake is here. 24 times by 4 is 96. So that should have been 96, that should have been 96, and we've got a mistake here. So 96 there, 96 there, And then 96 minus 32 would be 64. And then when I add those together, I would get 278. There we go. So that's my answer for the surface area, 278. Okay, question 10. Table shows information about the profit made each day at a cricket club on 100 days. Complete the cumulative frequency table. And then I'm assuming we're going to draw it. Yeah. And then make some interpretations on it. Okay, right. So cumulative frequency we find by adding the frequencies together that have happened so far. So first cumulative frequency is 10. Second cumulative frequency is 10 plus 15. So we're looking at 25. Then plus 25 becomes 50. Plus 30 becomes 80. Plus 5 becomes 85. And then plus 15 becomes 100. So we then need to plot that on our graph. So we're looking at, we plot at the maximum points. So we would plot this as 50, 10, and so on. So 125. So I'll plot those points. So we're looking at 50 and 10. We're looking at 125. We're looking at 150 and 50. We're then looking at 280. And then finally we're looking at, not finally, 250 and 85. And then finally 300 and 100. And then you need to try and draw that a smoother curve. I wouldn't go to 0, 0. I would just do, I don't think you'd lose a mark, but I wouldn't join it to the origin. So I'm going to put this in with a, so let me try that again. Mine should be an exceptionally smooth curve. Yours will be slightly less smooth, I would imagine, but you should have the same general pattern. So that's my cumulative frequency graph drawn. And then we start looking at these questions. Use your graph to find an estimate for the number of days of which the profit was less than 125. So profit less than 125, we go up to our graph. From our graph, we go across. So we're looking at, well, that's 30. We're going up in twos, so I'm going to go what looks like 36. Use your graph to estimate the interquartile range. So the interquartile range, if we're looking at 100, so that would be our full, 50 would be our median, 75 would be our upper quartile, and 25 would be our lower quartile. So we're reading off these values, so that's quite a comfortable one. So we've got 100 there for our lower quartile, or Q1. And then for Q3, 75. So that's looking like there. So if I read down, so these are going up in 150, 160, 170. It looks like 175 or 170 to be slightly more accurate. Q3. So the interquartile range is going to be the largest, subtract the smaller. So I've got my value wrong here. Let's just look again. 150, 60, 70, 80, 85, 185 is a better one. So my interquartile range is going to be 185 minus 100. So I'm looking at 85. And just looking at the mark scheme for this, because we're reading off our graphs and we're drawing our graphs, there's a range of error. So you can have anything between 35 and 39 for this one, and for this one, anything between 85, so mine's quite low, up to 95 would be fine. Okay, question 11. Cormac has some sweets in a bag. The sweets are lime, strawberry, or orange. And we've got our ratios, but we've got algebra involved in our ratio for the number of orange sweets. Cormac is going to take at random a sweet from the bag. The probability that the sweet is lime, which is this one, is 3 over 7. Okay, so work out the value of x. So, okay, you can do this a few ways. I'm going to use a ratio. I think this is going to be the easiest way for me to look at it. 9 to 4 to x. And then if we've got a ratio of 3 to 7, lime to the others, then in effect, to get from there to there, you're dividing by, so if I convert that back into nines, so that's going to be 9 to 28. So x plus 4 needs to be equal to 28. So looking at this, so I've messed up here. That shouldn't have been 7, and also I timed it wrong. So let's rewind a little bit. So if there are 3 parts lime, it means that to make a total of 7 parts, there must be 4 parts. So if I times that by 3, I would get 12. So 4 plus x must equal 12. So x must equal 8. There we go. So x is 8. Okay, question 12. Express 0.117 reoccurring as a fraction. You must show all your workings. So I'm going to go x is equal to 0.1, 1 reoccurring, 7 reoccurring. So I'm going to go, I've got a 2-digit reoccurring pattern, so I'm going to times by 100. So my patterns overlap. So that's going to be 11.717 reoccurring. So 99x is going to be equal to this one, take away this one, so that's going to be 11.6. So x is going to be equal to 11.6 over 99. So I'm going to say that that is 116 over 990. And then it doesn't, I'm going to cancel it down. It says a fraction, but I'm going to cancel it down. Both of them are definitely divisible by 2. They're not both divisible by 4. That's not divisible by 4. So I think I can only cancel by 2. So I'm going to go 98 over 495. So 58 over 495. Although, because of the wording of the question, I think you would be absolutely fine with 116 over 990. Okay, question 13. A right angle triangle is formed by the diameters of 3 semicircles, region A, B, and C, as shown in the diagram. So A, B, and C. The area of show that the area of region A is equal to the area of region B, which is equal to the area of region C. So we're going to base this around Pythagoras' theorem of A squared plus B. A squared is equal to B squared plus C squared. So we'll come back to that. But for now, if I call this length A, this length B, this length C, then the area created by the semicircle of A, so the area of A is going to be equal to pi r squared. So actually it's going to be a half of pi times by the radius, which would be a over 2 squared. So that's going to be equal to 4 over 2. So that's actually going to be equal to pi times by a squared over 8. If I look at the area of B is going to be equal to the area of B. Actually, let's put a colon there instead of an equals. Is going to be equal to, by a similar process, a times by B squared over 8. And then we'd do C as well. So C is going to be equal to the area of C is going to be equal to pi times by C squared over 8. So if I come back to this, what I'm going to do now is, if I look at a squared is equal to b squared plus c squared, then I'm going to times all those by both sides by pi over 8. So that's going to give me a squared pi over 8 is equal to b squared over 8 plus pi times b squared over 8 plus pi times b squared over 8. So that means that the area of A is equal to the area of B. Let me rewrite that. The area of B plus the area of C, which is what we were asked to show. Okay, right, so question 14, here is a speed time graph. Work out an estimate for the gradient, and then what does the area under the curve represent? Okay, so we're going to look first of all at t is equal to 2, so I want to find the gradient of the curve at this point. And the way I'm going to do that is I'm going to draw a tangent to the curve. So I want to insert a line. So this is going to be so I want to move this. So I'm going to try to move this so that I've got a line that just touches the graph. And I think that's a pretty good tangent. There we go. So I'm going to go for that as my tangent. So I need to work out the gradient of that tangent. So I'm going to look at a nice big triangle created by that. So I've gone up 5 and I've gone across 2, 4, 5.4. So the gradient of the graph is going to be 5 divided by 5.4, which is going to be equal to 5 divided by 54. And I'm going to leave it like that. It's going to be about 0.9, but we're going to leave it as 5 over 54. Okay, what does the area under the graph represent? Well, the area of a speed time graph represents the distance travelled, because if you think about it, the area is going to be found by meters per second times by time in seconds. So the seconds would cancel, so we're just left with meters. So it will be the distance travelled. So what does the area represent? The distance travelled. Okay, question 15. A, B, C are 3 points such that AB is 3A plus 4B and AC is 15A plus 20B. prove that ABC lie on a straight line. Okay, so if I say that AC is equal to, and then factorize it by taking a factor of 5 out, that would be 5A plus 4B. So it's equal to 5 lots of AB. So AB and AC are parallel. As AC is a multiple. And they both start at A. So must be on a line. Be on a straight line. Okay, D, E and F are 3 points on a straight line such that D to E is 3E plus 6F. E to F is minus 10.5E minus 21F. Find the ratio of the length of DF to the length of DE. Okay, for this, first of all, we haven't actually got DF, so we need to work out DF first of all. If you think, regardless of the vectors, we've got D, E and F on a straight line, so we know D to E and we know E to F. We want to first of all find D to F. So D to F is going to be equal to D to E plus E to F. D to E plus E to F. So we are trying to do minus 3E minus 10.5E is going to be minus 7.5E. And then plus 6 minus 21 is going to be minus 15. So I shouldn't have put a plus there. Minus 21F. Right, I'm going to factorize that in a specific way because I want to have 3E plus 6 in my inside. So 3, that's going to be minus 2.5. So I'm going to take minus 2.5 out as a common factor and say that that's going to be minus 2.5 times by 3E plus 6F. Right, so in effect that means that DF is equal to minus 2.5 DE. Right, so minus 3.5. Sorry, minus 2.5 is 5 over 2, so I'm going to just rewrite that as DF is going to be equal to 5 over 2 EF, DE, sorry, DE. So 2 lots of DF is going to be equal to minus 5 lots of DE. Okay, so that's in terms of the vectors. So that is, technically speaking, in terms of the vectors, vector has a distance and a direction. So if I put the vectors in terms of a ratio, so I would need So in terms of a ratio, in terms of the vectors, I've got, I would need 5 lots of DF would be equal to minus 2 lots of DE. That's in terms of the vectors, but we can't really have a negative length. So in terms of length, that's going to be 5 to 2. So in terms of length, that's going to be 5 to 2. Okay, question 16. First aid test has two parts, a theory test and a practical test. The probability of passing the theory test is 0.75. The probability of passing only one of the two parts is 0.36. The two events are independent. Work out the probability of passing the practical test. Okay, so if I, to help me explain this, I'm going to set it up as a tree diagram. So the probability of passing the theory is 0.75. So pass, fail is 0.75. So the probability of failing it is 0.25. Right, for the practical, I'll call that PR. For the practical, the probability, well, we've got, let's do the other way around, pass and fail, pass and fail. And what we're actually trying to work out is the probability that they pass. So we're trying to work this out, so I'm going to call this X for now. This probability of failing is going to be 1 minus X because they need to add up to 1. And then likewise here, X and 1 minus X. Right, we want these two branches, this one and this one. So we know, well, we know what that probability is. We're going to use that though. So we're going to say 0.75 times by 1 minus X plus 0.25 times by X is going to be equal to 0.36. So that's that information there. Right, and now we just need to attempt to solve that. So if we look, that's going to give us 0.75 minus 0.75x plus 0.25x is going to be equal to 0.36. So if we do a little bit of a rearrangement here, so technically this is, I've missed my 5 off there. So we'll tidy this up one more time. 0.75 minus 0.5x has to be equal to 0.36. So now I'm going to take my x's over to the right and my numbers over to the left. So 0.75 minus 0.36 is going to be 0.39, and that's going to be equal to 0.5x. So if I double that, x would be equal to 0.78. So x is going to be 0.78. Question 17. Y is directly proportional to the square root of t. We're given two values. T is inversely proportional to the cube of x, and we're given two values. Find a formula for y in terms of x. Okay, so if y is directly proportional to the square root of t, so y is directly proportional to the square root of t. And then the second one gives us the information that t is inversely proportional to the cube of x, so x cubed. So we're going to form two general equations of proportionality, plug in these values, and then we're going to have to combine them. So if I start with y is going to be equal to k times root t. So when y is 15, t is equal to 9, so the square root of 9 is 3. So k is going to be equal to 5. So my actual equation would be y is equal to 5 root t. For the second equation then, I'm going to start by saying that t is going to be equal to k over x cubed. So when t is 8, x is equal to 2. So k is going to be equal to t times, I'll substitute in, 8 times by 8. So k is going to be equal to 64. So my actual equation for that is t is going to be equal to 64 over x cubed. Okay, find a formula for y in terms of x. So we want it as y is equal to, so I'm going to substitute in this value for this value. So y is going to be equal to 5 times by the square root of 64 over x cubed. So square root of 64 is 8. 5 times 8 is 40. So it's 40 over the square root of x cubed. I think that will be fine for your answer. I'm going to go slightly different for my answer. So I could call that 3 over 2. So what I'm actually going to call it is minus 3 over 2. So I'm going to say y is going to be equal to 40x to the power minus 3 over 2. Okay, question 18. Work out the value of. Okay, so I'm going to convert these to being improper fractions as my first step. So that's going to become 5 times 9 is going to be 45 plus 9 is going to be 49 over 9 to the power of minus a half times by, and then if we do this one as well, so that'd be 12, 14 over 3. And I want to divide that by 2 to the power minus 3. Right, so if I square root that first of all, and do the negative reciprocal, the reciprocal of that and square root at the same time would give me 3 over 7 times by 14 over 3. Okay, so this is starting to tidy up nicely. So that's going to become, that would cancel with that twice, and that would cancel with that. So in effect, what we've got is 2, and then if we look, well, 2 to the power 2 to the minus 3. So we've got 2 to the power 1 divided by 2 to the power minus 3. So we subtract the powers, so that's going to become 2 to the power 4. And then as a final step, 2 to the power 4 is 4 times 4 is 16. So that's actually equal to 16. So we go 16. Tidied up very nicely. Okay, question 19. So solving algebraic fractions. So I'm going to get rid of my denominator part. So I'm going to times through both sides of the equation by 2x minus 1 times by x minus 1. So that's on both sides of the equation. So if I times this first fraction by that, this part in the numerator would cancel. This part in the denominator would cancel, so I'd just be left with times by x minus 1. If I times the second fraction by it, then the denominator would cancel with this part, so that would leave me with just 3 lots of 2x minus 1. And then that's going to be equal to, if I expand this bracket, that would be 2x squared minus 2x minus x would be minus 3x, and then minus 1 times minus 1 is plus 1. Let's just double check. 2x squared minus 2 minus 3x plus 1. Yeah, I'm happy with that. So now I'm going to tidy the left hand side up. So x plus 6x is going to be 7x. Minus 1 minus 3 is going to be minus 4. And that's going to be equal to 2x squared minus 3x plus 1. I'm going to take everything over to the right hand side. So that's going to give me 0 is going to be equal to 2x squared. Minus 3 minus 7 is going to be minus 10x. And then plus 1 plus 1 plus 1 plus 4 would be plus 5. Right, give your answer in the form, I'm going to assume that this doesn't factorise. Well, I'm going to state that it doesn't factorise. So I can either solve by using the formula or by completing the square. I'm going to solve by completing the square. So I'm going to say that that's going to be the same as, if I take 2 out as a common factor, x squared minus 5x plus 5 then if I complete the square on the first two terms alone, I'm going to put it into a square bracket. That's just kind of my habit for this. So that's going to be x squared minus half of that, so that would be minus 5 over 2 squared, and then from that, that's going to end up being 25 over 4 bigger, so I need to subtract 25 over 4 to make it those two terms the same size, and then plus 5. So I can drop this big bracket now and say that that's going to be two lots of I didn't need that square there, x minus 5 over 2 squared. That would give me 25 over 2, so minus 25 over 2 plus 10 over 2. So my completed square will give me two lots of x minus 5 halves squared, and then that's going to be minus 15 over 2. So now I'm going to rearrange this. My goal is to find x, so I'm going to take the 15 over 2 over to the other side, so that's going to give me 15 over 2 is going to be equal to two lots of x minus 5 over 2 all squared. If I divide both sides by 2, then that's going to give me 15 over 4 is going to be equal to x minus 5 over 2 squared. Then going to square root both sides, so that will give me plus or minus 15 over root 15 over 2 is equal to x minus 5 over 2. So then if I add 5 over 2 onto both sides, I would get x is equal to 5 plus or minus root 15 over 2. What format did it want? That's absolutely fine as my format, so I'm going 5 plus or minus root 15 over 2. So x is equal to. Okay, question 20. A circle of the center of a circle is the point with coordinates minus 1, 3. The point A with coordinates 6, 8 lies on the circle. Find an equation for the tangent to the circle at A, giving your answer in the form ax plus by plus c is equal to 0, where a, b, and c are integers. Okay, so the first thing I want to do is to work out the gradient of the radius to the point here. So in effect, I am looking at between 6 and 8 and minus 1 and 3, and I want the gradient between those 2 points. So I'm going to call it gradient of the radius is going to be equal to the difference in the y coordinates is going to be 5, and the difference in the x coordinates is also not going to be 5, is going to be 7. Okay, so the gradient of the tangent then is going to be the negative reciprocal of that, so it will be minus 7 over 5. And we know a coordinate on the line, so we are I'll do two methods for this. So one is more of a GCSE solution, one's more of an A level. So method 1 is going to be, I'm going to say that y is going to be equal to minus 7 over 5 x plus c, and I'm going to use the coordinate minus 1, 3 to work out the value of c, so that's going to give me 3 is going to be equal to minus 7 over 5 times by minus 1. plus c, so that's going to give me 3 is going to be equal to 7 over 5 plus c. So c is going to be equal to, let's call 3 15 over 5 minus 7 over 5. So that's going to be 8 over 5. So now I need to do a bit of a rearrangement to get it in the form that the question asked me. So I'm going to say y is going to be equal to minus 7 over 5x plus 8 over 5. I'm going to times through by 5, so 5y So I've just been trying to work this through and I think I've spotted a mistake. Have you already spotted it? So I've said that the circle passes through this point to find my value for c, but that's not right. The circle passed through 6, 8. So that should have been 6, 8. So I've messed up from there onwards. So if I take these values out, we should be able to work through c properly. And have a better equation. So let's look at that. When x is 6, y is 8. So that should have been 8 times by 6 there. So that would have been 8. That would have been 6 times minus 42 over 5. So c is going to be equal to, well, that would be 40 over 5 plus 42 over 5. So that would have been 82 over 5. So c would have been 82 over 5. So y would have been equal to minus 7/5 of x plus 82 over 5. So if I times through by 5 again, 5y is going to be equal to minus 7x plus 82. If I then rearrange it into the form that they asked for, that would have been, it was x first, 7x plus 5y minus 82 is equal to 0. And then I'll do, excuse me, okay, and then I'm going to do a slightly different method from here, just as a kind of an alternative. So gradient is the difference in the y coordinates, so that would have been y minus this value over x minus this value is equal to the gradient, which was minus 7 over 5. So if I rearrange that, that would give me 5y minus 40 is equal to minus 7y, sorry, minus 7x plus 42. If I then rearrange that, that gives me 7x plus 5y minus 82 is equal to 0. So that's a slightly quicker way of doing it. Okay, question 21. This was the one that students came out of the exam questioning me over. So this diagram shows 3 circles, each a radius 4 centimeters. The centers of the circles are A, B, and C, such that ABC forms a straight line. AB and BC are both equal to 4. Work out the total area of the 2 shaded regions, given your answer in terms of pi. So the key to this, or that really helped here, is the fact that what we've actually got is equilateral triangles, which would all be 60. And then I've actually got an equilateral triangle there as well. So those are all 60. And if you think about the area of one of these triangles, the area of this section here is actually equal to the area of one of those triangles, subtract the area of this, and then we just double it. So the way I'm going to do that is if I work out the area of the triangle and then the area of the sector. So the area of the triangle is going to be equal to a half of AB sine C. I don't really need that bracket in there, but there we go. So that's going to be a half of 4 times 4. Let me just double check that. AB, yeah, half of 4 times 4 times by sine c. The sine of 60 is root 3 over 2. So in effect, we can cancel those by that. So we're just left with the area of the triangle being 4 root 3. So the area of the sector then, the area of the sector, so that's the area of a triangle, the area of the full sector would be equal to 60 over 360 times by pi times by r squared. So that's going to be times by 4 squared. So that's going to be 1 1/6 times by pi times by 16, and we can cancel that by 8. So the area of that is going to be 8 pi. Right, so the area of the sliver, that sliver there, is going to be equal to the area of the sector minus the area of the triangle. So the area of the segment is going to be equal to 8 pi minus 4 root 3. And I could take out a factor of 4, but I'm not going to bother. So the total area of the total area of the sector that I'm after, and I need to double it after at the end, is going to be equal to, so the shaded area, so the area shaded is going to be equal to the area of the triangle, minus one of the sectors. So it's going to be equal to 4 root 3 minus 8 pi minus 4 root 3. So that's going to be 8 root 3 minus 8 pi. So that we want the total shaded area. Oh, and I've just spotted a slight mistake again. That should have been over 3. Because I missed off when I cancelled by 2, that would have left a 3 there. So apologies, that would have been a 3 there. So I am looking at having a 3 there. So that would be my area of my shaded area. So the total area total is going to be 2 times that. So if I write times by 2 there, so that's going to be 16 root 3 minus 16 over 3 pi. Do I want to simplify that? I could take a factor of 16 out. It doesn't really make it much simpler though, so I'm going to go for that as my answer. Okay, that brings us to the end of the paper. Okay, hope you found that really useful. Like I say, past papers are probably my number one go-to in terms of revision, particularly for a paper 1. Here is a list of the topics. So that's this is quite a nice spreadsheet from Edexcel. Should really hide that though. But it doesn't really matter. So those are the questions. So those are the 21 questions that were covered, and each of the topic skills. So if, for example, you struggled, most probably 21, arc length, angles, and area of sectors of circles, that's where you are going to focus your revision before whichever exam you're preparing for. So I hope you found that useful. Please ask any questions or comments. Feel free to type them into the chat for this. I'll get back to you fairly quickly. And please remember, subscribe if you like.